let's see how we can implement redirection mechanisms. Before talking about them, let's start with the basics. Okay, let's start with the simplest possible situation in which the user directly downloads content from MyTube. So the user writes mytube.com in his browser, and as you may know, the name mytube.com is not sufficient to contact any server, any physical server. We need first to resolve this name into an IP address, and to do so we use DNS, Domain Name Service. I will not go into the details of DNS, but in general it is a distributed system made of different servers which deals with DNS query coming from clients asking to resolve names like www.mytube.com, and which replies with an IP address, XXXX in this case. So if you want to make your website MyTube reachable to the rest of the internet, you have to register your website to the DNS system. In order to do so, you first need to install a server, not only the server where the actual content is, but also a server that will act as authoritative server for MyTube. So this is actually where all the DNS queries related to mytube.com will be sent, and it will reply with an actual IP address. Oh, for instance, if your DNS server receives a request for www.mytube.com, it may reply with XXXX. If it receives a DNS query for mail.mytube.com, it will reply with YYYY, etc. with another server. I mean, I'm assuming you have different servers. And so your DNS server that will be handled by yourself may reply to different DNS queries with different addresses. Okay. So how can you announce your DNS server to the rest of the internet? Well, you have to contact a registrar. In particular, in this case, you will contact the registrar responsible for the name .com. Okay. These are organizations that you contact, you pay them, and you say, look, I am a new website, my name is mytube.com, and my DNS server has address XXXD. So whenever you receive DNS queries for mytube.com, please forward these DNS queries to my server at XXXD. So if you do so, now you are reachable from the rest of the internet. And now the DNS queries from the clients will go to your DNS server, and you will be able to reply with the addresses you like. So suppose you have a cluster of servers. One is XXXX, another is XXXA, etc. Now, if a user comes, a DNS query comes, you may reply with the address of the first server. If another query comes, you may reply with an IP address of another of your servers, etc. And in this way, you can implement a load balancing strategy. Okay. However, apart from these details, now, in some way, the browser of the user knows the IP address of your content server, XXXX. Thanks to this, the browser can open a TCP connection to your server, and then on top of it, it can open a TLS channel. So from now on, all the transmission is encrypted, and inside this channel, the browser will start to send HTTP requests, HTTP GET request. Usually the first request is for index.html. And so your server will reply with the page index.html. In this page, there will be different kinds of content, etc. And usually there will be links to other content. For instance, links to the videos of MyTube, with usually the thumbnails and the title. Whenever a user clicks on one of these links, it is actually sending a GET request for the specific video. For instance, if the user clicks on video A, actually it will send HTTP GET request for the video A. And these requests will arrive to the same server and the video will be transmitted. So far so good. Now let's see what happens if you now want to use the services of a CDN. The first thing you have to do is that you need to transmit all your content to the CDN, because the CDN needs to ingest it. You usually do it via a front end that is a sort of portal that the CDN provides. And so you send your content to this front end, and the CDN will start to distribute it in its own nodes, distributed all over the world. And now an actual redirection mechanism must be implemented. I recall that the redirection is something that allows the users to have the impression to download content from MyTube server, but in reality the user has been redirected to a CDN node. And we have three main ways to make a redirection happen: URL rewriting, CNAME, and domain hosting. Let's start with the first one. So this is the same picture as before. Now I'm just adding the CDN node. All the steps are as before, okay? So there is a DNS resolution. The browser now knows the IP address of the MyTube server, and it downloads an index.html. But look at this. So now the links are modified. So the first link is no more for mytube.com/videoa, but it's for node1.cdn.com/videoa. This means that whenever a user will click on the first link, it will not download the video from MyTube server, but from the CDN node, in this case node 1. So this is conceptually simple. Of course, okay, before sending the HTTP GET to the CDN1 node, another DNS resolution must happen to solve www.node1.cdn.com to an IP address, etc. But this is not important for us. What I want to say is that this technique of URL rewriting is very conceptually simple, but then difficult to put in practice for MyTube, because they have to change their HTML pages and replace all the links with the redirection to the CDN node, and this is not simple. Moreover, the load balancing strategy must be taken care of by the MyTube server, because if you want to distribute requests to CDN node 1, 2, 3 to load balance, you have to for every user change the page index.html, replacing every time the links. So this is complicated for MyTube, and this is why this URL rewriting is not used a lot. An alternative is to use another technique called CNAME, which relies on a DNS protocol function called CNAME. Actually, this is another way of calling it is alias. What happens is that first, this is the same picture as before, okay? I just added also the authoritative DNS server for the CDN, okay? And observe that the actual content server of MyTube doesn't do does nothing anymore. Okay, you see, it is out of the game. Okay, let's see how this technique works. So as usual, the browser first tries to solve mytube.com, and as usual this DNS query goes to the authoritative server of MyTube. This time MyTube doesn't reply directly with an IP address, but replies with an alias. Actually, it is saying that if you are searching for mytube.com, go and search cdn.com instead. So in other words, you're saying that cdn.com is equivalent to mytube.com. So this reply will go to the DNS client that will now try to solve cdn.com. Therefore, this DNS query will go to the DNS server of CDN that will reply with the IP address of one of its nodes. So now the client, the browser, will open a TCP connection directly with the CDN node using the IP address YYYY. So you see that now MyTube server is not involved anymore. So, and MyTube doesn't have to deal with changing index.html, etc. It doesn't need to do anything. Okay, so this technique is easier to use for MyTube, and it's preferred over the one. There is another technique, and another thing I want to say is that the load balancing decisions are taken by the authoritative DNS server for the CDN, because this CDN server can decide to reply to some users with a server YYYY, to other users with the server ZZZ, etc. So the load balancing happens here. There is another technique that is even easier for the MyTube server, that is called domain hosting. Observe already that here not only the MyTube server, content server, doesn't do anything, but also the authoritative DNS server of MyTube doesn't do anything. So actually MyTube is not doing anything here. So let's see how this thing is implemented. As usual, there is a DNS query coming from the browser of the user, and actually this DNS query goes directly to the DNS server of CDN. How is it possible? Well, this means that CDN is hosting the domain of MyTube. This means that when MyTube registered its website to the register of .com, instead of communicating its own CDN server address, it provided the the IP address of the CDN. So in other words, MyTube called the register and said, look, I am a new website, my name is mytube.com, and the IP address of my DNS server is YYYY, which is the IP address of the DNS. Is the IP address of the CDN. Okay? So in other words, you're hosting your own name entirely into the CDN. So from now on, all the requests to MyTube, even the DNS queries toward mytube.com, go directly to CDN. So MyTube is completely out of the game. They don't have to do anything anymore. They don't even have to handle a DNS server. So this is why this solution is the easiest for MyTube, for the content provider. But also, I mean, they really need to trust CDNs, because now there is no easy way for MyTube to stop using CDNs. So if for some reason MyTube and the CDN don't agree anymore, or the CDN starts to act maliciously, Well, MyTube cannot do anything immediately because all the traffic toward MyTube is now redirected to CDN from the beginning already. Anyways, this seems to be the most used solution in the internet nowadays. So this means that content providers really trust CDNs. They are sure that CDNs are not malicious. And of course, you may say, well, this is risky, and actually it is, but this is how things work up to now. To recap, we have seen three redirection mechanisms. The first is URL rewriting, in which the MyTube server replies directly to the users with a modified index .html, where all the links point to CDN nodes. And the advantage of this is that MyTube has a fine-grained control over its content, because it can decide to send to serve one content via a certain node of a CDN, another video, it can point another video toward another CDN node or maybe another CDN company, etc. So if you modify properly index.html, you have a very fine-grained control over the redirection of your videos. But it's a bit difficult for MyTube to modify index.html for every user and to do load balancing. So other easier approaches are CNAME and domain hosting. In the first case, DNS queries toward mytube.com still go to MyTube DNS server, which will reply with the IP address of a CDN node. In domain hosting instead, MyTube doesn't receive not even DNS queries. Okay? Directly MyTube is registered to DNS system with the IP address of a CDN node. So all the DNS queries will be directly forwarded to CDNs. And so this is the easiest approach for MyTube, for a content provider. Another quite complicated aspect of CDNs is authentication. Let's see what it means. So we have seen that nowadays most of the traffic is under HTTPS. This means that when a user connects to a server, it first creates a TCP connection, and inside this TCP connection, a TLS channel is established. TLS stands for Transport Layer Security, and this channel encrypts all the information exchanged between the server and the user. And so all HTTP requests and replies are actually encrypted inside this TLS channel. When a client instantiates a TLS channel to a server, supposed to a MyTube server, it first needs to be sure that on the other side the node is actually MyTube and it is not anyone else, an attacker, a malicious user who is impersonating MyTube. To do so, we use asymmetric cryptography. This means that the server, MyTube in this case, needs to have a pair of keys, a private and a public key. The public key, as the name suggests, is announced to everyone, it's announced to the world, it's public, while the private key is only known by MyTube itself. Now, whenever a browser of a user wants to connect to MyTube, it first sends, inside the TCP connection, it sends a random number. Okay? Then MyTube has to show it is really MyTube. To do so, it signs the random number plus a certificate. And actually signing means just to apply a function, a mathematical function. With these inputs, certificate, we will see what it is, it's not important now, and the random number received. And this function is parameterized with the private key. So actually this signature can be done correctly just by MyTube. Okay, so the result of this mathematical function that we call S is sent back to the user, to the browser. And now the browser needs to do the inverse of the signature by applying this time the public key. And the result, hopefully, is equal to the input of the signature. So this is the magic of asymmetric cryptography. Asymmetric cryptographic functions, like these ones, are such that if you have a pair of keys, private and public, and you sign with one and you inverse with the other, the inversion works. It means that after the inversion you will find exactly the same input of the original function. So actually, if the inversion works, this is a proof that the node we are talking to is actually MyTube. So to understand it better, suppose now there is an attacker that is impersonating MyTube. Actually, the attacker just knows the public key of MyTube, but doesn't know the private key, because it is private by definition. So a browser connects to the node, hoping it is MyTube. Actually, the node is an attacker, and the node, what it can do is just applying a signature, but it doesn't have the correct private key. It just uses another key, okay, another parameter, another number. And then, okay, the message S is created and is sent back to the browser. When the browser does the verification, the inversion, it will use the public key, and the result will not be corresponding to certificate and random, okay, will be wrong. Why? Because the original signature was not done with the correct private key associated with this public key, and so the inversion doesn't work. So to recap, MyTube can show that it is actually MyTube because it is the only one who is able to sign information, certificate and random in this case, such that the inversion with the public key actually works. Any other attacker, they don't have the correct private key, so they will not be able to produce a signature that is correctly invertible. Okay. So at this point, the browser knows it is talking with the real MyTube node. So at this point, there is an exchange encrypted with the public key of MyTube of session keys. So this means that these keys are sent encrypted with the public key of MyTube, and so only MyTube is able to decrypt the session keys. And these keys will be used to encrypt the actual content, the actual video information that will be exchanged between MyTube and the browser. I want to stress here that when you open a TLS channel, there is a first phase of authentication, which relies on asymmetric cryptography, and in which the browser just makes sure that it is talking with an actual MyTube node. Then there is another phase that starts with the exchange of symmetric cryptographic keys, and this phase starts here visually, and from this point on all the content will be encrypted with the session keys. So private and public key from this point on will not be used anymore, but these session keys that change every time will be used to encrypt the actual content. Now, I already mentioned to you this certificate. What is it? It is just a digital document a textual document where you have information like the name of an organization, address, etc., and also the public key of the organizations. Only the public key, of course, because again the private key is just known by MyTube. So this certificate is circulated over the internet, and this is how browsers can verify that they are talking with MyTube. So actually all the users know the certificate of MyTube when they want to talk with MyTube. So, but we need a way to avoid fake certificates, because otherwise a random attacker can create a certificate claiming that MyTube is associated with a certain public key, which is not the correct one. So to avoid this, we have our certification authorities. There are few certification authorities in the internet, and their role is to sign certificates. So to, in other words, declare certificates that are correct or not. How do they do it? Well, they just apply a signature as well by using their own private keys. Okay, I don't want to go into the details of certification authorities, but what happens is, if you're MyTube and you want to open a website, okay, what you have to do is register to DNS, etc. And in addition, you have also to contact a certification authority. So you have first to generate a pair of private and public keys, and this can be done very easily via a command in Linux and in Windows. I mean, it's a line of a command actually. And then you will store private key securely in your computer, and you will request a certificate to the certification authority, to one of the certification authorities that exist in the internet. And you will say, look, I'm MyTube, this is my address, this is the name of the responsible, etc., and this is my public key. The certification authority will make some verification, making phone calls, they will check if the company really exists, etc., and then they will if everything is correct, they will create a certificate, meaning that they will sign the couple MyTube and public key with their own signature. From now on, all the browsers will trust this certificate, because they will each browser knows already a set of certification authority. So whenever it receives a certificate signed by one of these authorities, they will assume this certificate is correct. Strangely, this is just a curiosity, each browser trusts a different subset of certification authorities, which may create confusion sometimes, and which also opens a lot of possibility of attacks. But we will not have time to go into these details. So before going on, let's take 1 minute to recap, to put together some of the pieces we have seen. So you opened a new website called MyTube. So the first thing you did is that you registered your website to the DNS registrar. Maybe we have seen this before. Okay. Now another thing you need to do is to generate a certificate, and to contact a certification authority in order for them to sign the certificate. So this certificate will be distributed all over the internet, and can be known by all the browsers. And in fact, if now a browser tries to contact with MyTube, it will first create a TCP connection, then it will start a TLS handshake to create a TLS channel. To do so, it first generates a random number and send it to MyTube. Now MyTube has to show that it is really MyTube. To do so, it applies a signature by using its own private key to the certificate and the random number received. And it sends back the signature as well as the certificate itself. Now the browser will apply the inverse function and will find again the certificate and the random number. And so it can say, okay, the node on the other side was able to sign in a correct way because applying the inverse function, I obtain the certificate and random. So this looks good. The other node, it seems I can trust the other node. But first, what the browser will do is to read the certificate and see if it has been signed by a trusted certification authority. That is what happened at the beginning. If the browser finds a signature of a valid certification authority, then that's okay. The browser will trust the node on the other side and it will start to exchange data by first exchanging keys for symmetric encryption. Now, this is authentication, okay? Let's now see how authentication is coupled with redirection mechanisms. Let's start with the first redirection mechanism, URL rewriting. And with this, actually, the authentication is simple and actually is separated. It means that first the browser will authenticate MyTube, then the browser will request index.html, and then if the user clicks on one of the links, the browser will request the content node.cdn.com. This means that the browser will now authenticate cdn.com. So with URL rewriting, there are two authentications. The first one is of MyTube, just to retrieve index. The second one is of CDN to get the video. Things get more complicated with the other two redirection mechanisms we've seen, that are CNAME and domain hosting. Indeed, with CNAME, what you do is that the DNS replies to the browser with the IP address of a CDN node. So now the browser will contact a CDN node, and actually the CDN node should be able to prove it is MyTube, okay, because the browser is trying to access MyTube. So how can CDN impersonate MyTube? This is a complicated problem. So the simplest thing one may think of is this one, the first one, meaning that when MyTube wants to use the services of CDN, it just sends to CDN not only the content itself, but also the key pairs. So MyTube sends also the public and the private key to CDN. Like this, CDN can apply the signature with the private key as it was MyTube. In this way, CDN can impersonate MyTube with all the users. And you may observe that this violates the nature of asymmetric cryptography, because asymmetric cryptography assumes that private key is just in the hands of the a valid owner. While in this case, MyTube is disclosing the private key to the CDN node. And it is clear that this is a security issue, but this is how a lot of CDNs work. They ask their the content providers to send the private key. This means that content providers have really to trust CDNs, and if the CDNs start to make malicious actions impersonating MyTube, MyTube cannot do anything. So this may seem absurd, but this is one of the used solutions nowadays in the internet. Another solution that is a bit better is the shared certificate, and it is used by some content delivery networks like Incapsula and Cloudflare. Of course, things may change with time, so maybe now that I'm talking, these companies are using different strategies. But anyways, what I'm saying, it was true up to 2014 and 2015, at least. So how does a shared certificate work? So suppose MyTube wants to use the services of a CDN. So MyTube manager signs a contract with CDN, etc. There is an agreement. Now CDN contacts the certification authority saying, please add to the certificate of CDN also the name of MyTube. You see, what it will be created is a certificate where the same public key, that is the public key of the CDN, is associated not only to CDN but also to MyTube. So this means that whenever a browser wants to authenticate a MyTube node, the CDN is able to successfully prove it is MyTube, because the CDN has MyTube name into its own certificate. So CDN can use its private key to prove it is MyTube. So, of course, the CDN asks the certification authority to add MyTube name to the certificate of CDN. The certification authority will not accept right away. They will try to contact MyTube saying, look, is it true that you want your MyTube name to be added to the certificate of CDN? And the responsible of MyTube will say, yes, I was in contact with the CDN, so everything is okay. And after this, the certification authority will modify the certificate of CDN by adding MyTube. But of course, here again, CDN like this is able to impersonate MyTube. And so if the CDN wants to start malicious actions in the name of MyTube, they can do it. So this is again a security issue, but still it is one of the most used solutions nowadays. Another solution, the third and last that we will see, is keyless TLS. That is more or less new. It was patented by Akamai, but so far it is only implemented by Cloudflare. So far, I mean, last time I checked this information, maybe things have changed now. So how does it work? So here the certificate remains in the hand of MyTube. I mean, there is no shared certificate or whatever. The good thing about this solution is that there is a certificate of MyTube completely separated from CDN, and the private key just remains to MyTube. We don't need to disclose it to CDN. So what happens is that the client contacts, okay, via DNS redirection, via the redirection mechanism we have seen, the browser will contact the CDN node and will send the usual random number. The CDN node will not reply directly, but it will forward this message to MyTube. MyTube is able to sign correctly to produce a valid proof of its identity. So it can sign its certificate and the random number. And this message will be sent back to the browser and also to the CDN node. But this is not important. The browser now will apply the inverse function, and we see the inversion worked. So actually the node who replied was the correct one. But for the browser, the node who replies is the CDN. So far the CDN believes that the CDN node is MyTube. So the browser doesn't know that behind the scenes CDN has just played the man in the middle. Okay? Anyways, the browser will trust this communication and will produce session keys to be used for encrypting the actual video content, and will send session keys encrypted with the public key of MyTube. This is the focal point here. Now, it's true that CDN is a man in the middle here, but CDN will not be able to decrypt the session keys, because the only way to decrypt it is to have the right private key, and the right private key is only in the hand of MyTube. So CDN will not be able to do anything. So the only one who will be able to find the session keys is MyTube, and MyTube will send the session keys to CDN, so that now CDN can decrypt the requests coming from the browser and can also send the video content correctly encrypted. So what is the advantage of this approach? Well, first, the private key remains in the hand of MyTube. Second, MyTube has its own certificates, so CDN cannot impersonate MyTube. So if CDN starts to act maliciously, MyTube can just stop to use it, and to do so, it suffices not to send session keys to CDN. So if MyTube doesn't do this, the browser cannot communicate in any way with the CDN. So we can say that this keyless TLS allows MyTube to remain in control of its own identity and prevent CDN to impersonate MyTube in all the ways. However, this is a quite new approach and it is not used a lot. The previous two are the ones that are used the most. And it is curious that CDNs emphasize this aspect of security. So they call their product Akamai Secure CDN. Cloudflare says that the goal of delivering content as quickly, cheaply, reliably, and securely as possible, blah, blah, blah. But actually, the mechanisms of authentication on which they rely are all except secure. So they can just work because these CDNs are big names, and so everybody trusts Akamai, Cloudflare, and Limelight. Everybody assumes they will not act maliciously. Still, we hope that new techniques like keyless TLS will slowly be used, and maybe other techniques will also be adopted in the future.